Thank you. So hopefully people can now see me speaking. Yep, okay, I've been spotlighted. So I'm Emma Cliffe. I work at the University of Bath, where I head up the Mathematics Resources Centre. But I've also, over the last 15 years, had a particular interest in disabled students accessing degree courses which contain substantial quantities of mathematics. I've worked with some blind and visually impaired students, but also a large number of dyslexic students, students on the autistic spectrum, etc. There are other people out there who specialise more in things like dyslexia. I focus on the technical and practical aspects of getting a screen reader to work, for instance. Now, I don't have slides, I have a document and some things I'm going to try and show you because I really like to make life as hard as possible for myself. I'm not going to get through everything in the document, but it's there live and there's lots of links in it you can follow of places you can get started with things, some of which are simple, some of which are much harder. I'm also unlikely to be able to cover everything because this is a huge area. So I'm going to share my screen and also my sound. So hopefully you can now all see a web page which is entitled Accessible Maths e-resources. I can no longer see anyone else, so for all I know, I'm talking to no one right now. So I'm going to try and focus on where do you start. But first of all is understanding why it's important to think about it. Then what is it, kind of basically speaking, you need to do, and then places to get started. So why is it important? Well, I'm not a lawyer, and you should talk to your own institution's lawyers about how they interpret what you need to do. But there is a legal requirement. The Equality Act 2010 sets that out in the first instance, and there's quite clear guidance to higher education institutions about, for instance, making accessible electronic notes. But more recently, there is the snazzily named Public Sector Bodies Websites and Mobile Applications #2 Accessibility Regulations. Your institution will have by now, by law, a statement about accessibility somewhere on their website, because this law kicked in last September, October time. But there's a secondary date, which is this kind of September time, where more things kick in about what has to be done. And we need to have our eyes on that. Now, this is about websites and mobile applications, but it includes in it virtual learning environments and every document that is put on them as well. So this is quite wide-ranging in its scope. If you want to learn more about the legal requirements, then AbilityNet have got some great webinars and some resources which help, really aimed at the higher education sector, which help you to understand these requirements more. But actually, I think we should carry in a different way, because if you look at the mathematics subject benchmark, it states that mathematics at university level is characterized by the need for a high degree of conceptual and abstract thinking within the learning process. And we want students to have the processing capacity to engage with those concepts and abstract thinking. But if a student has a print disability or difficulties with taking notes, with memory, with concentration, they might be spending substantial amounts of processing capacity on entirely different tasks. And that's true whether they're physically located on campus or at the other end of a computer. But now, in this kind of tricky time we live in, all students, except those at the Open University, who are new to e-learning, they're trying to find new ways to learn and consume mathematics. And this will require them to interact with resources in new ways, and that will impact their processing capacity. So I think it's not just an access thing right now. So what do you need to do? Generally speaking, we need to make it possible to access and consume information in a variety of ways. Okay? All students, but especially those with e.g. dyslexia, will benefit from interactive, responsive resources, which are colourful, well-rendered mathematics and graphics, enriched by video and audio. Go for it. Quizzes, all these kind of interactive things that people are talking about, absolutely. But such resources can raise practical and technical barriers for other disabled students, in particular those using a screen reader or who need to have text content read aloud, so they're sighted but they are dyslexic, so they need text read aloud perhaps. People who are colourblind, where colour is being used for meaning. Poor graphics that don't magnify or zoom well. Dynamic pages which have got multiple things going on simultaneously are hard for VI users. So we've got a kind of almost a difficulty here in that the needs of some and the needs of others are actually kind of against each other in some ways. So there's no magic thing that you do which makes everything accessible for everybody. But there are some things that we know are a real problem. So computers and the assistive technology that some students will use to e.g. have maths read aloud to them, they rely on structural integrity to process that maths. So what I mean by that is, if I have typed a fraction in, then the piece or the document I have needs to retain the connection between the two different parts of the fraction and the fact it is a fraction. Now PDF does not retain that. It doesn't matter whether it came from LaTeX, from Word, it doesn't retain that information. It's lost when you create the PDF. Print, obviously, it's lost then. Handwriting, it's lost, except for if you can see it. And ebooks which use images of maths, websites that use images of maths also can't be processed. So these formats are all inaccessible and inflexible, but also not just from an access point of view, but also on small screen devices. So just treat them as a lossy format for maths. Imagine that if you do this, some member of your audience won't be able to access that mathematical content. On the other hand, we have Word, HTML-based formats, EPUB 3. They have structural integrity for maths, and they're accessible to many assistive tech. But, and this is the moment in time we live in right now, not all of the assistive technology that all different students will use can access maths in all the different formats. So one screen reader user will be able to access maths in Word documents, and another will be able to access maths in EPUB and another in HTML, but they can't swap between. So we need to provide as much choice as possible as we can. PowerPoint 365 is theoretically accessible, but most assistive technology won't work with it yet, and it can't be transformed to other formats. So if possible, stay away from PowerPoint right now. So using assistive tech effectively for the maths does require the authors to do something to produce accessible materials. So how do you get started? So from a technical point of view, you need to be producing all of your content, all of the things that the learner needs to be able to access in one of those three formats, and ideally more than one. HTML using MathJax to render the mathematics, Word, or EPUB 3. And earlier, and I've borrowed the word spine from, I think it was Katie earlier, supply the course content spine in that format. Ensure that it's all there in that format. You also need to supply PDF though. Even though I'm saying it's inaccessible, for some students, it's actually the best thing. So it won't help you meet the legal requirement, but a clear print PDF is the format most often selected by the disabled students in the Department of Mathematical Sciences at Bath. We provide all of these formats, but that's the one most of them select. So you've got a large range of formats that you might want to produce. I'm going to go through some of those formats now. So you might be producing web straight out. Now that might be because you're using something like Numbas or Stack, and so you're working on a web-based thing. You might be typing pages straight into Moodle. So what is it that you need to meet? You need to meet the legal requirement of WC AG 2.1 level AA. That's the new requirement, which comes in September. And you can check that using a variety of kind of plugins to Chrome. Accessibility Insights for Web plugin is probably the easiest to pick up and use, but there's many others. Ideally, you want someone else to do that hard work for you. So ideally, you want to be working in the system where you know the kind of standard thing you're producing already meets that, and so you're not having to do lots of checking. What those things won't do is check that the maths is accessible. So to check its MathJax, which is what you need, right-click on it. If it says about MathJax help, then that's accessible mathematics. You don't need to think any further about that. Why MathJax? It provides navigation, chunking, so someone can move through the equation piece by piece when they're hearing it. People can zoom to very high zoom. People can copy and paste. You can use color. You can also allow size and layout changes. So for instance, if I want to change the line height here, it's not affecting the mathematics. If I want to change my font to something that dyslexic students might find useful, I can do that in this resource. I can also turn on a high contrasting. So just by producing accessible web pages, but also the MathJax maths within them, people have a lot of flexibility to meet their own needs. And the structural integrity of MathJax enables the assistive technology. So that will plug in, either the assistive technology will directly interact with the MathJax itself, but if it can't, and it's something called ARIA aware, which you don't need to worry about if you don't know what that is, then it can use a fallback with MathJax provides. And this is not just screen readers and text-to-speech, but also electronic braille. So some VLEs will enable you to create pages which meet these requirements using LaTeX for the maths, for the equations, immediately straight out of the box, as long as it's configured correctly. So talk to your central learning and teaching team about that. So we can do that in Moodle. Okay, what if you're in Word? So again, you've got that one extra step. So first of all, you need your Word document to be accessible according to the Word accessibility checker. But then what it won't check for you, you need to ensure that you've written all mathematical text using Word 365 equation editor. And that includes even single letters. So a variable x, this is a piece of mathematical text. The variable theta, it's a piece of mathematical text. Don't use symbol insert, never write subscripts or superscripts or fractions using font or style changes or standard keyboard input alone. Never use an image of an equation. So I can just download the accessible Word format of this, which has been made all from the same master. And if I open that, so editing. Okay, so we can see I've got my contents page. If I just scroll down a bit, we can see this is the same document that we were looking at before. Now, how do I check it for accessibility? First of all, I might need to convert it if it's a slightly older version. And then if I go into review, I can check accessibility. Now, I didn't have to make this accessible because the way I generated it made it accessible for me. But I can also read aloud.
Check it is MathJax. Right click. X equals numerator, minus b plus or minus square root of b squared minus 4amc end square root, end numerator, over 2am. Provides / enables.
Stop that. So those are the three things that you do basically to check your Word document. Is first of all, use the inbuilt accessibility checker, make sure your mathematical text is how it is, and then listen to it and it should read aloud correctly. There's a link there which takes you to some workshop resources I've made previously, which will take you through those steps in more detail. Okay. Accessible diagrams and interactive dynamic elements. I've been adding to this to try and kind of meet some of the questions that were coming up. So this is a long list. Interactive dynamic. So first of all, if it's a piece of software or another system like Numbast, then first of all, check with the vendor, the people that produce it, that it meets the WCAG 2.1 level AA requirements, and get your university to procure on that basis. Don't do the hard work. Get the other people to do it for you. Okay. Check the mathematics is rendered via MathJax, because that won't be covered in that accessibility check. So that's other pieces of software. Get them to do the work. Then you can use it knowing you're producing something accessible. If you're using video, you do need to add subtitles or closed captions. Now, we're not all in the happy place the Open University is. We don't have a team of people who do this for us. So the best way we found of doing it without procuring anything is upload to YouTube, wait for automatic captions to be provided, download those as a transcript, correct those in a text editor, upload them again, get YouTube to sync back, and then download as subtitles and add that to your video as a subtitle track, or you can just embed from YouTube. It's actually pretty good, even with mathematical content. You're going to have to do some punctuation, and there'll be mathematical terminology you'll want to capitalize or not capitalize or correct the spelling of, but it actually does a fairly good job. To me, handwriting is an interactive or dynamic element. It's not something we should be scanning and making into a fixed document that isn't accessible. But handwriting is an important thing in mathematics, and if we never do any handwriting, it's going to make it less accessible for the majority of people. So if you treat it as an interactive and dynamic element on top of a spine of accessible content, where anything you're handwriting is somewhere else in an accessible format, then I'm not a lawyer, but I suspect that's within the law. But you want to check with your institution on their take on that. My take is don't avoid using something if it currently can't be made technically accessible, but is important for other sorts of access. So handwriting isn't, GeoGebra is not fully accessible, but these are really great things for other disabled students. Someone who's dyslexic will find a handwritten video kind of going through something, or a GeoGebra applet which is dynamic, much more accessible than the print. So provide an alternative way to access the same content or experience that you're providing with that dynamic or interactive thing, whatever it is. So for instance, if you've got that spine of accessible materials, remove the proof from it, and then go and handwrite that proof in and talk aloud and add to it, but make sure you're saying, you know, I'm on line, you know, this is the proof of theorem 2.1, and we're currently on line 2 of it. So that if someone is using a screen reader, they can follow along on the accessible full materials and they know what you're doing. The important thing the law does say is that you have to tell people what is and isn't accessible and who to contact if there's a problem, and you have to know what you will do when they contact you. We do have some fully accessible dynamic interactive tools. One of them is Desmos, which a lot of work has gone into to make that accessible. I have no idea how I'm going for time. Kevin, feel free to tell me.
We're going badly for time.
Badly. Am I over?
Slightly, shall we say? Shall we be diplomatic?
Yeah, okay. I won't demonstrate that, but we can get that read aloud in effect as a graph. We can hear it, and it can also be brailled automatically by the student. If you're a specialist in R, then the Braille R package can be used to make some sorts of graphs automatically accessible. If you've created the diagram from code or data, provide that code or data so the student can use that themselves. For all other diagrams, you will need to do some training, and there are links there for how you will do that. I've also put a note in that about some mathematical diagrams, it's the wrong thing to do to try and produce a lengthy textual description. And actually the right thing to do is say, actually, you need to have a one-to-one meeting with me if you can't see this, and we'll go through it or whatever. Okay, my final bit, and this is very quick. The elephant in the room, what about LaTeX? So the past, where we're trying to move on from about now, is using tools which may or may not work, that cannot tell us why something doesn't work, and that in general can't possibly convert LaTeX. We were using those because we didn't have any other choice. So try not to fall back onto those. I've linked to the one that we currently use, but I don't suggest it. The future might be things like LWARP, which is a LaTeX package, which a lot of work has gone into, which will make HTML as output, and I think possibly EPUB, though I haven't tried it. The documentation currently runs to 1,237 pages though, and whether it will work will depend on what you're doing in LaTeX, and you'll have to work that out for yourself and test accessibility for yourself. The easiest method right now is to use R Markdown or Bookdown, incorporating LaTeX for the equations and a simple markup language for the rest. This resource has been made using actually Bookdown, which gives you things like theorems, theorem environments, and also numbering. And we are writing something at Bath to try and kind of go on top of Bookdown, which gives you access to things like new theorem types and theorem type sharing numbering, so fixing some of the things that Bookdown hasn't dealt with. What does this look like if you're actually doing it? So this is what my source of my presentation or document looks like, and one button press, I'm able to produce Gitbook, which is what you were looking at to start off with, a flatter Word HTML document, which is better for some people, Word, PDF in various formats, and EPUB, and you can explore those in your own time. And I think at that point I will say that I am done, and thank you for listening.
Okay, thank you very much. Right, so we've got, we don't have much time for questions, but there are a load of questions, so maybe you're going to have to do a lot of typing up. But, I'm
happy to answer them via typing, so you can move on with time if that's better.
Yeah, and I should have said what people should preface the question by typing @ and the name of the speaker. So there are well, there's a lot of questions about LaTeX, and that's the one thing you didn't say much about. Well, I suppose you did say something about MathJax. But somebody does say, how many of these issues can be mitigated by providing the LaTeX source alongside a PDF? If you just give the LaTeX source.
Mm-hmm. Can you render LaTeX in your head without ever rendering it to PDF? Because that's effectively what you're asking someone to do if they're blind. I can do that. I think most people find that hard.
No, I think the thing is that if you give them the LaTeX, then they can perhaps have their own way of doing things.
Yeah. So
should we be providing as...
You provide them with the full training and the tools in order to do that. But what I'm saying right now is actually the tools are really hard to use. And I think that would be putting quite a large barrier in front of a student who already has other barriers.
Mm-hmm. Well, I was thinking more of a sort of like an extra, just
yeah, sure,
some sort of help, you know.
Yeah.
A good thing to do.
Yeah, provide as many formats as you can.
Right, and here's the one I was thinking I'd like to know about. So, tips for how to make graphs, especially for statistical data analysis, more accessible. Do you just have to provide this sort of like a written description? Yeah.
The best thing for statistical graphs is to use the Braille package, or in fact actually just do everything in R and then provide the R source to the student and make sure they know how to use Braille R. So Braille R is developed by a group of blind statisticians, and it produces interactive descriptions and sometimes graphical interactive things with kind of structural descriptions. Also, it plugs that person into a community of blind statisticians, peers, that they can learn from. So if you actually genuinely have a student who is a screen reader user and you are doing statistics, which is beyond Excel, then that would be the right way of doing it. And the contact for that is Jonathan Godfrey, who is in New Zealand, and he's kind of the world specialist on that, and he's a blind statistician.
Okay, good. Hopefully somebody will stick that name in the chat for us. Okay, well, thank you very much for that. I think we should be moving on, and perhaps you'll be able to answer some questions during the next talk.
Yeah, I'll keep typing.
So thank you very much. Thank you very much for that.